Welcome to Part 2 of a 3-part tutorial series on the lane geometry input dialog in SIDRA Intersection 7. In this video, we'll demonstrate how to use this input dialog to specify lane configuration and lane disciplines in SIDRA Intersection 7 using a sign control site as an example. Note that the Lane Geometry Part 1, 2, and 3 video tutorials on different intersection types can be viewed independently. For demonstration purposes, we will continue using the sign control site modified in the intersection and movement definitions video tutorials. Open the latest project you saved that contains the site named Sign Control 2L. Rename the site as Sign Control 3L and then save the project. Click the Layout command in the ribbon to view the picture of the T intersection. If you have not gone through the steps described in the tutorials for the intersection and movement definitions dialogues, here is a summary of what has been demonstrated so far. We added a two-way stop sign control site to a new project. In the intersection dialog, we modified several parameters, deleted the south leg, and rotated the site twice so that the major road is in north-south direction. In the movement definitions dialog, we introduced large trucks as a new movement class. It is very important that you use the lane geometry dialog to specify lane configuration and lane discipline data immediately after the movement definitions dialog. Click Lane Geometry in the Site Input section to open the dialog. Click the View Layout button at top right to view the layout picture to the right of the dialog. As you select approaches and lanes in this dialog, the selected lanes will be highlighted in the layout picture. You can view the updated layout picture as you make changes to the lane configuration. The first tab in the Lane Geometry dialog is the Lane Configuration tab. The Approach selector displays the diagram of the two-way stop sign control site configured in the intersection dialog. The Lane Editor displays the approach and exit lanes specific to the legs selected in the Approach selector. Approach and exit lane numbers are shown in the Lane Editor display. You can select an approach lane or an exit lane by clicking a lane, using the F2 and Shift F2 keys, or using the mouse wheel. You can configure the selected lane using the parameters in the Lane Configuration data group. Approach lanes, exit lanes, and strip islands can be added or deleted in this dialog using the command buttons below the Lane Editor picture under both the Lane Configuration and Lane Disciplines tabs. Add and delete functions are also available when you right-click a lane or strip island in the Lane Editor picture under both tabs. Let's first change the configuration of Approach Lane 2 on the south leg from a full-length lane to a short lane. Note that when the selected lane configuration is a short lane, an additional section will appear at the bottom of the dialog. Separate lane length parameters apply to short lanes. Let's modify the short lane length. Now, we will add a new approach lane on the south leg for large trucks only. Select Lane 1 and click the left arrow on the App Lane command button. Alternatively, right-click Lane 1 and select Add Approach Lane to Left from the drop-down list. Select Lane 1 and enter TR in the Lane ID field and select a color. Let's also specify an exit lane for the large trucks. Select the north leg and exit Lane 1. Enter the same ID and the color used for the approach lane. Let's add strip islands between the exit and approach lanes on the north and south legs. On the north leg, select Approach Lane 2 and click the right arrow on the Strip Island command button to add a strip island between the approach and exit lanes. Alternatively, right-click Approach Lane 2 and select Add Strip Island to Right from the drop-down list. Select the south leg and insert a strip island between the approach and exit lanes. Now, let's change the strip island parameters. On the north leg, while the strip island is selected, increase both the front and back widths. Select the south leg and increase the back width of the strip island. The lane geometry specifications are not completed yet. If you click Apply or OK before allocating all OD movements to appropriate lanes, you will get a lane configuration error. Click Cancel to close the message box. The second tab in the Lane Geometry dialog is the Lane Disciplines tab. Click the tab to allocate all origin-destination (OD) movements by movement class to appropriate lanes. You must allocate each movement class to at least one lane on any approach. Check the movements on the layout display as you allocate them to approach lanes. First, select Lane 1 of the south leg, and then assign OD movements from south to north for large trucks by checking the box under heading T1. Then uncheck the boxes next to light vehicles and heavy vehicles to remove these movement classes from this lane. Now select Lane 3 and remove all movements from south to north by double-clicking the arrow labeled T1 or unchecking the boxes individually next to light and heavy vehicles under it. By default, the lane editor displays OD movements by all movement classes on each lane. The drop-down list, Show Lane Disciplines By, helps to check lane disciplines when different classes are allocated to different lanes. The third tab in the Lane Geometry dialog is the Lane Data tab. This includes the approach lane data for all site types. For detailed description of the parameters available under this tab, please refer to the user guide. When the lane geometry configuration specifications are completed, click OK to close the dialog. Save your project. Clicking the Process button at this stage will give an error message. Other necessary data specifications must be completed in the remaining input dialogs before results are obtained. This concludes Part 2 of our tutorial on the Lane Geometry Input Dialog in SIDRA Intersection 7. Please refer to the other tutorials in this series to learn how to configure the lane geometry for a roundabout site and a signalized intersection site.